In this video, we are going to look at empirical and molecular formula of organic compounds given the known masses of the elements in the compound. Can you like and subscribe to the channel after watching? When we say empirical formula, then we mean the smallest ratio that the atoms in a compound or molecule can exist. And the molecular formula is the opposite, the largest ratio that atoms in a molecule or compound can exist. So let's take a compound like, let's say, a compound AB existing as, let's say, 2, 3. This one means that in this compound we have 2 atoms of A and 3 atoms of B. So the ratio of these atoms in this compound is 2:3. In the same way, this compound can also exist as A4B6. In this one, the ratio is 4:6. Now when we take this one, this is the smallest ratio that these atoms in this compound can exist. So the smallest ratio defines the empirical formula, and if it is the largest ratio, this one becomes the molecular formula. So here, this formula is the empirical formula of, let's say, this compound, a guessed compound, and this one is the molecular formula of this compound. Basically, when you want to deduce the molecular formula from an empirical formula, we find what we call an empirical unit. Then you multiply it by the empirical formula. The empirical formula, or the empirical unit, so the empirical unit is given by the molecular mass over the empirical mass. So if you want something like this, the molecular mass is the atomic mass of, or the mass of the molecular formula, then the empirical mass is the mass of the empirical formula. So let's assume that in this case, the empirical mass is, let's say 30. Then the molecular mass is, let's say, 60. The empirical unit is that fact that you have to multiply by the empirical formula to get the molecular formula. So here, when you divide this one by this, you are going to get 2. So it means if you want to deduce the molecular formula from the empirical formula, you multiply the empirical formula by 2. We are going to take practical examples so that we understand better. So take this formula in your head, that the empirical unit is given by the molecular mass over the empirical mass. The empirical unit is the factor that you have to multiply by the empirical mass to get the molecular mass. Let's take this example and solve so that we understand better. So we have these 2 set of questions that we are going to solve for today. Then we bring our lesson to an end. The practice problem 1 says that a hydrocarbon has a molecular mass of 30 grams. Calculate its empirical and molecular formula if it contains 80% of carbon. So a hydrocarbon, this one, you have to mean that when you talk of hydrocarbon, then a compound containing carbon and hydrogen. So this percentage means that when you take 100 grams of the hydrocarbon, 80 grams of the entire mass is carbon. So then this one means that the mass of the hydrogen is also equal to 100 times 80, which is 20. So the hydrocarbon contains 20% of the hydrogen. This compound contains only carbon and hydrogen. And from this question, it says that 80 of them is carbon. It means the remaining is hydrogen. And to find the mass of the hydrogen, you have to subtract the 80 from 100 because it's percentage. The first step that you have to do when you are given the masses of, the element in a compound to deduce the empirical and molecular formula is to first find the number of moles of each of the atoms in a molecule. And the number of moles is given by the mass over molar mass. So if you want to find the number of moles of each of these atoms, carbon and hydrogen, you are going to take the mass of the carbon alone divided by the atomic mass of carbon, then the mass of the hydrogen alone, then divided by the atomic mass of hydrogen. So the first thing you have to do is to determine the number of moles of the individual atoms. So the number of moles of hydrogen is equal to the mass of the hydrogen, which is 20, over the molar mass, or the atomic mass of hydrogen, which is 1. Hydrogen has atomic mass of 1 and is constant, so keep that in your mind. So we are going to get 20 moles. Next is to find the number of moles of the carbon. So the number of moles of the carbon is equal to the mass of the carbon, which is the 80 given the question, over the atomic mass of carbon, which is 12. This one is constant. Atomic mass of carbon is 12, is constant, so keep that one in your head. So let's proceed. And this one is going to give you 6.67, that's approximately 6.67 moles. Having got this, the next step, the first step is to find the number of moles of each of the atoms by dividing the atomic mass of the atom by the given masses. The next step is when you take the two given moles, or the moles of the given element, you take the smaller one, then divide it by the larger one. So here we have the smaller mole, which is 6.63, which is out of carbon, and out of the hydrogen is what? Is 20. So you are going to divide this one by this, and this one is by this. So the ratio of the carbon is equal to, the minimum ratio is equal to 20 over 6.67, which is 2.9. So this one is approximately 3. Sorry, this one is the ratio of the hydrogen, the ratio of the hydrogen. This 20 is that of the hydrogen, so 2.23. So this 3 means that the minimum ratio that the hydrogen exists in this compound is 3. Now, the ratio of the carbon is 6.67 divided by 6.67, which is 1. So this 1 and this 3 is the minimum ratio that this atom, hydrogen and carbon, exist in the hydrocarbon CH. So the minimum ratio is 3 to the 1 is to 3. Therefore, this minimum ratio defines the empirical mass, also the empirical formula. So the empirical formula of the hydrocarbon is 1 of the carbon, then 3 of the hydrogen. So the empirical formula of the carbon, of the hydrocarbon having 80% of carbon and 20% of hydrogen is CH3. So this is the empirical formula. So you get done with the first part of the question, the empirical formula. Now for you to find the molecular formula, you have to find for the molecular mass and divided by the empirical mass. Here the molecular mass was given as 30, but the empirical mass is the mass of the empirical formula, which is, here is 12 plus, so here the empirical mass is 12 plus 3, which is 15. So this 15 is the empirical mass. Therefore, the empirical unit is equal to 30, which was given in the question, over 15, which is 2. So this 2 is the empirical unit, the factor you should multiply by the empirical formula to get a molecular formula. Therefore, the molecular formula is 2 times the CH3, which is the empirical formula. So this one is going to give you C2H6. So this one becomes the molecular formula of the compound having these masses. Let's take the second question. Now we have nylon having 63.3% of carbon, this percent of nitrogen, and as it goes. The next step, or the first step as usual, is to find the number of moles of each of these elements. We have number of moles of carbon, number of moles of nitrogen, number of moles of oxygen, the number of moles of hydrogen. So this one, we take the carbon. The number of moles is the mass of the carbon, which is 63.38 divided by 12, which is the atomic mass of carbon. And this one gives you 5.282. Then it comes to that of the nitrogen, which is 12.38 over the atomic mass of nitrogen, which is 14. This one gives you 0.884. These are the number of moles. That of the oxygen, number of moles of the oxygen is the mass of the given oxygen, which is 14.14 divided by the mass of oxygen, which is 16. The atomic mass of oxygen is constant, which is 16. That gives you also 0.884. Now we come to the number of moles of hydrogen. The mass of the hydrogen in the question is 9.8, so it becomes 9.8 over 1. This one is the atomic mass of hydrogen, which is the same as 9.8. So each of these are the number of moles of the individual element. The next step, as usual, as we did for the first one, is to divide each of these number of moles by the minimum figure. So here we have 0.884, this one as the minimum figures. So the ratios of the carbon is 5.282 over 0.884, and that gives you 5.98. So this one is approximately 6. If the first decimal place is more than 5 or more, then you approximate it to the nearest largest whole number. If the first decimal place is less than 5, then you approximate it to the nearest lower whole number. So here it becomes 6. That is the minimum ratio. Now that of the nitrogen becomes 0.884 over 0.884, which is 1. That of the oxygen too is 0.884 over 0.884, which is also 1. Now we come to the hydrogen. Hydrogen is 0. The mole is 9.8 over minimum figure, which is 0.884. This one gives you 11.09, which is approximately 11. So the ratio, the minimum ratios existing in the compound is 6:1:1:11. Therefore, the empirical formula is equal to the carbon is 6, the hydrogen is 11, the nitrogen is 1, then the oxygen is 1. So this is the empirical formula of the compound. Now, the molecular formula. For you to find the molecular formula, the question says you should find the molecular formula if this is the molecular mass. So you have to find the empirical mass first. So the empirical mass of the empirical formula here is carbon has 12, so it's 72. So 12 times is 72 plus 11 plus this one, like nitrogen is 14, then plus oxygen, which is 16. This one gives you 113. Therefore, the empirical mass is 113. So the empirical unit which must multiply this one is given by the empirical unit is given by the molecular formula given in the question, which is 339 over the empirical. This is the molecular mass, and this is the empirical mass, which is 113. This one gives you 3. Therefore, this 3 multiplies the empirical formula to give you the molecular formula. So it becomes 3 so this one becomes 3. So the 3, which is the empirical unit, multiplies the empirical formula, which is C6H11, then nitrogen, then oxygen, which is equal to, so let's turn the back of the paper. The empirical formula was C6H11, then nitrogen, then oxygen. This is the empirical formula. Then we had the empirical unit to be 3. Therefore, the molecular formula is given by the empirical unit times the molecular formula, which is 3, multiplying C6H11, nitrogen, then oxygen. So this one is basically C18, hydrogen 3, nitrogen 3, then oxygen 3. That's how it goes. So having got the empirical unit, then you multiply the empirical unit, which is 3, by the molecular formula. That will give you the final molecular formula. So now that is the end of the video. Kindly like and subscribe to the page. And if you don't understand anything, don't hesitate to email me. Thank you.